done stepped in the game? At point blank range, who done stepped in the game? At point blank range, who done stepped in the game? Stepped in the game, stepped in the game.
Okay, so I'm going to make this quick. You guys can see for yourself exactly what I'm addressing here, and we'll cut to that.
Let's talk about how software runs on the Switch. When you install a Switch game, it sits on top of the operating system known as Horizon OS. This physical game data itself comes built in with what's known as Nintendo Shared Object or NSO files, and this is not the same as the Nintendo Switch Online NSO that you may have heard of. These system objects that are brought in embeds a full Tegra X1 Maxwell GPU driver stack inside of every single Nintendo Switch game regardless of first or third party. Any shaders that are pre-compiled are also bundled with the game, and this is the root cause of the backward compatibility problem. A new SoC to power a new Switch hardware will simply not be binary compatible with this code, even though it's still on ARM64 architecture. Now you might be wondering, on my PC I can simply update my GPU drivers when I get a new graphics card, so why is it possible to do it on my PC but not possible to do it on a next generation piece of Nintendo hardware? Because the GPU driver stack is not statically bundled into the game. Drivers are installed externally to the game as a dependency, and when Nvidia updates its GPU drivers, you know it simply works because its legacy around that is known as the Unified Driver Architecture or UDA. This simply means that your existing games that target NVIDIA GPU driver stack will work on any updated drivers, and we know this to be true on the PC. On the Switch, however, UDA is mostly irrelevant because of its custom operating system Horizon OS, and again due to the embedded nature of the GPU driver stack. So the TLDR here is that if Nintendo is to move away from the Tegra X1, which we all feel strongly that they will probably do, then current Switch games won't work on new hardware. That is, without recompiling the games to target that hardware.
So the big issue here is we're talking about backwards compatibility with Switch now from whatever the new Switch successor would be. For all intents and purposes, we know it's more than likely going to be another NVIDIA device. So why do we think that there's going to be an issue with a Switch successor playing Switch games? We've had Nintendo, doing various different projects over the years, going from Game Boy to Game Boy Advance to DS to 3DS. All of them being backwards compatible with regards on the handheld side. And on the console side, we went from GameCube to Wii U to the point of Nintendo asking their engineers to do the impossible with IBM and create a CPU core that wasn't Mercy compliant and making it multi-core, therefore being Mercy compliant for Wii U, which kind of defies logic, but they somehow made it happen. They created their own science and did that, and also created a Wii out of Wii U to trick the Wii U into thinking it's a Wii by creating Wii mode for the Wii U, which is kind of insane the way they repurposed eDRAM of the Wii U to pretend to be one TS RAM. Obviously, Nintendo's engineers and their CPU engineers, they're pretty smart. So what we have here is a video from Modern Ventures Gamer, and of course a bunch of other people kind of jumped in on the fun, making a bunch of different YouTube videos. RGT made a video kind of talking about it and whatnot. So I figured I'd give my take on it, so you guys, I'm pretty sure y'all wanted to hear and understand what's going on here. So what MVG is talking about, he doesn't think that Switch games would be compatible with the future device, because that future device, he's assuming that it's going to be a couple generations newer. So instead of going from Maxwell to Pascal, it'll be going from Maxwell directly to Ampere, because that's what the T239 is being presumed to be inside of the Switch from some of the rumors. Tends to be. It has an Ampere GPU. So he's thinking there's going to be an issue with Maxwell having its draw calls and shaders the shader compilation that exists in games working on Amper, because it would take some type of translation. It wouldn't directly do that. Probably will with Pascal. For all intents and purposes, from everything that I researched, Pascal basically directly supports Maxwell shaders. So one solution would be to either put a Pascal or a Maxwell core in there to resolve this issue. But what essentially is being asked here is, he talks about code and how some of the games are compiled as packages. He talked about NSO being an object file that Nintendo Switch uses. That's essentially just an ELF. Essentially speaking, it's just a executable file format that this certain application uses. In this situation, it would be SDK or the Horizon OS to launch an executable, which would be a game, right? If you look at all the flags in there, they're pretty much the same. There's a couple of different headers and registers in there to make different calls to different resources, because obviously Switch has different system calls than, say, like a computer, right? So it has to know what it's asking for, so underneath the hardware layer it would know what to give it. But since games are executed in user space in the Switch OS and the Horizon OS, he's saying that, hey, if you try to run a game or put a Switch cartridge inside of a newer Switch console, all those shaders are compiled at runtime in user space while you're running that game, and they're already embedded within the game itself as an object. And only Maxwell understands how to handle those shaders and whatnot, and it only knows how to handle that object to run the code. A couple of issues when he started mentioning NSO is when you start talking about binaries and how to run executables. That's not really a problem for the ARM architecture, because ARM version 8, really ARM version 7 going forward, they're pretty much all binary compatible at this point. It goes without saying that the A57 in the Switch or what have you would be directly forward compatible with the A78 that would be in Amper if that was going to be the CPU that Nintendo chose to use. So pretty much all the code that will be designated for the A57 on the Switch would be directly compatible in the A78. So right there, running the NSO or the ELF, for lack of a better word, wouldn't be an issue. The only issue would happen is, hey, you run main code, and then you start executing the shader compilation, right? Then that would be an issue, because there's binary code in there that talks directly to the Maxwell GPU. And if you have newer hardware that isn't backwards compatible with Maxwell, which we're assuming is the situation because we were talking about Ampere, and how that could be a problem. Well, there's multiple ways to tackle that issue. So either you find a way to precompile shaders and translate them from the Maxwell ones that are already existing, and have those calculated for whatever the new GPU is going to be. And either there's a little wait, or you have them pre-baked into the OS, so it knows what to do when it gets a request for any old Switch game, what to do, which will require that you have basically a database of all the old shaders for every Switch game. And it knows what to call and how to pull them. They may be sitting in a page in RAM somewhere, so when the game requests them, it's just like, no, just look here, look at this page in RAM or whatever, and it pulls all the shaders back that way. Because they have to go in memory anyway. That's the whole reason you're compiling the shaders, so they can be held in RAM, right? But if they're already in RAM from the OS, because it knows that you just put a Switch game in, you can play a little bit of double jeopardy there. The other solution could be literally just having the SoC there. So if you had Maxwell or Pascal GPU in there, it would, I mean, even if it was just served as an auxiliary chip, maybe you just put it in there and it's a security chip, or it just runs the OS, and it also doubles as, hey, you know what, whenever you run a game, run it in Switch mode or whatever, and it compiles the shaders for the Switch game, and then there's no thinking for the new GPU to do. And that's similar to what happens with Wii and Wii U. That's kind of how that works. When it detects a previous generation game, it goes into that mode and it knows what to do to accept it. That could be what Nintendo's working on, because that is what they've done in the past. So the other issue, when we're talking about the game code itself, that's a decision that Nintendo chose, and it'll always be compatible because Nintendo chose to use a microkernel. So with regards to how kernels work, you have different ways that operating systems are laid out. You have your normal monolithic kernel, which would be like, say, regular Linux or regular Windows or what have you. They have one giant kernel that has all the tasks sitting where you have, like, say, your applications, you have your, and then one layer, and that's pretty much the only thing the user can touch. And then in between that, you have all the privilege mode stuff that the operating system handles, but you have to be like a system administrator or something like that to be able to handle those tasks, or it's an automated task handled by the kernel itself. So like access to the file system, access to memory and stuff like that, all that stuff is being passed to you as you run the application at a higher level as a user. You don't get access to that stuff. The privilege exec mode of the kernel activates a lot of that stuff. So that would be for like a giant operating system. So all your drivers and all this stuff sit down in that space. Well, what Nintendo chose to do was something a little bit different. They chose to use a microkernel operating system. So the way that works is they have the drivers exist in user space along with the application. So you've got a situation where you run a game, the drivers and the shaders and whatnot are being requested by you to then point to the rest of the kernel, and the rest of the kernel will say, oh, okay, well, you're running this game. All right, I will present you with this amount of memory that's been translated to you. It's not the real memory, it's a translated version of memory, so there's no corruption going on in case you're running bad code. And here's these lines or whatever to the GPU. You can talk directly to the GPU, but only through this little lane that we're giving you as part of the microkernel. Essentially what happens is you have an application and then you run in user mode. The kernel will pass you everything that you need. So it will go into the file system and whatnot and show you everything that you need going forward. Or like it could be kind of like a hybrid type situation where you only get bits and pieces of it. You may have full access to the file server, but you may not have access to any of the instructions for the CPU or the device drivers. Those will all be embedded to the kernel. So since Nintendo is using the microkernel, what happens is you only get access to the application and the device drivers and shaders. That's it. And they run in user mode or user land, as some of you guys are used to on the IT side of things. And kernel space is running all the other processes, like your true memory locations, your true system calls, so all the other devices that make the switch go, power and things of that nature suspend. Those are applications, or those are requests that are sent down to the hardware, and then they do the thing that you want them to do. Nintendo going to continue doing that. They're going to have that same microkernel situation going forward with whatever the Switch's successor would be, regardless of what form factor it would be. Because if backwards compatibility is going to be their primary focus, they want to keep that same operating system style going forward, so there's no confusion. Especially if you want to stay binary compatible on the CPU side of things, the memory side of things, and if you're going to have an issue with the GPU, it should just be the GPU and shader situation, and that can be resolved in numerous ways that you can convert and translate shaders either in the background or before you run the game, pre-compiled or whatever as you're requesting it. I don't want people to think, hey, the new Switch can't even run the old Switch code. That's not necessarily true. Those CPUs can run whatever kind of binaries you throw them. That's fine. The memory is just a space, so that's just a storage mechanism. So it'll hold whatever you send it. And then the GPU, which would be the only different situation here. should be able to compile shaders that are sent to it. Now, the only reason it wouldn't is if in the situation that MEG is talking about, it is that big of a jump. And if it is that big of a jump, then yeah, there will have to be some type of translation there, or there will have to be patches, as he said. I don't think Nintendo would do that. I think they want universal compatibility. So what they'll probably do is either pre-stage them in firmware, and they'll already be requested as you try to run said game, or they'll have some type of translation layer there, so it would just run. It would basically be a just-in-time run environment. So as soon as, hey, you are an old Switch game, let me translate all these shaders to Ampere so Ampere understands what you're requesting, and then go from there. And I'm pretty sure that's something that they're working on with NVIDIA, or probably since 2016, of how to go forward with what they planned on doing. So yeah, I don't really think that's an issue, but I wanted to make sure that a lot of the misconceptions are out of the way. I don't want people thinking, oh, well, it just can't run code and things like that. That's not exactly the way that it works. As long as you know that on this system, the drivers exist in user land and not kernel space, and kernel space runs a lot of the system calls and stuff like that. But Nintendo could put that, they can configure that however they want it. If a monolithic kernel was used to replace Horizon OS going forward, I doubt that, because Nintendo loves security. That's the whole reason they chose a microkernel to begin with. Because if you try to create a game, or you try to, how can I say this, create the Twilight hack again, that can't work technically on Switch, because you don't get real memory space when you try to buffer overrun the game. It's all requested, because there's what's called address space layout randomization in between the kernel space and the user space there. So you don't get a real memory address whenever you request something as an application provided by the user, or the developer even in this case. What you get is some hexadecimal space that you request, and you get some random hexadecimal space that's actually applied underneath that went directly to the hardware that mapped it somewhere completely different. So you don't really get to see what's happening to you, because what you just requested in memory is sandboxed away from you. You can't really get there. So, but yeah, that's the way it's designed. It's a low-level microkernel environment. So, and I was probably, worst case scenario, if Nintendo is going forward with doing something different, it'll probably be a hybrid kernel, or they would just keep microkernel. That's pretty much what I think they would do. They'll probably just stay the course, and the successor to Horizon OS will be very similar to what Horizon OS is now. So some things I want to be clear here. So Switch's CPU, for the most part, is totally forward compatible with any future CPU its successor will have. So it's likely that it's going to be the A78, but they are directly binary compatible. So I want to get that straight. The OS from the Switch will be compatible with how its successor will address game drivers and shader compilation in user space, because Nintendo would keep the same microkernel layout for the successor to Horizon OS. So, like I said, that means that going forward, even Switch 2 games will compile shaders in user land, just like how you would expect for both developers and users. So, yep. And so, like, only Maxwell shaders potentially serve as a problem, as I mentioned before, if and only if Nintendo skips from Pascal to Ampere, right? Even then, a translation layer can be approached to convert Maxwell code to Ampere code on the fly. That's pretty much how that will work. Nintendo can also offer one-to-one native translation by adding a Maxwell or Pascal core to the SoC. Obviously, this will increase the price, more than likely, because you're putting another SoC inside of there. What is not true? Switch's games won't require patches on the new hardware. As I said, this will only be true if Nintendo doesn't have a just-in-time implementation for Maxwell drivers and shaders. What also isn't true? The new Switch won't have issues with system resources. And that's because Nintendo can translate all the system calls themselves. They know everything. A new Switch won't have issues with system resources. Nintendo can absolutely translate system calls to make anything pretend to be a native Switch, even with different OSs if they wanted to. And the reason why, because they have all the answers and they know where to point everything. They wrote and authored Horizon OS. They own the kernel. They wrote the kernel. So your CPU type, GPU type, memory configuration, or what have you, is almost irrelevant if Nintendo approves it and the translation layer is available for it. So it's a clear answer how Nintendo wishes to proceed forward with NVIDIA on holding new hardware several generations from now. So I don't really think it's an issue. Switch could literally live in a hypervisor as a virtual machine, and to be honest with you, I think some people in the know have already seen this in action. So, which is it's kind of a cute tale. The other thing that's not true: Switch is still not confirmed to have the T239. So the project exists. It's evidenced by the tweets from last year. And of course, Dr.81, he did a little bit of digging. He does his LinkedIn thing and whatnot. So we confirmed that the chip exists. We know that it exists, but we don't have a direct tie yet. T39 doesn't directly point to NVN, and NVN2 doesn't directly point to Switch 2, because even in the leaks for that, it's a little bit nebulous. All you have is a folder full of different classes of Ampere hardware, and we have no idea which one they would end up using. So it's like Nintendo kind of left it wide open, like, hey, in case you guys get hacked, nobody's gonna know what we're using, because we just put a whole family in there for anybody to try to guess through. So that's what they do. I'm not surprised. Yeah, man, it's fun to speculate, but it kind of puts us all back at square one when you think about it. Nintendo is more than likely working with NVIDIA. That's kind of like the foregone conclusion. Pretty much everybody knows that. That's common sense at this point. But yet again, we still have no idea what specific kind of tech they're using. So honestly, my biggest question is the carts. How will we go forward with extra ROM capacities from Macronix? Like, it seems like they have the key. They really hold all the keys to how Nintendo games will be played in the future. And I want to know how we're going to get beyond 64 gigs, 128 gigs as game sizes balloon and balloon. Like, they're getting bigger every day, especially for third parties. So I wonder what the answer is for that. Either they go more flash, or they stay on the extra ROM route, which is prohibitively expensive, but maybe they know something we don't. No, that's it. Any questions, comments, or concerns, if you want to dig deeper into the realm of how kernels are operated, I can do videos on this. Just let me know how you want to go with this. But I thought this was a fun little topic to talk about. Extremely high level. We're talking on the technical level here, but I like to explain stuff to you guys so you understand a little bit better than to be treated like just a layman and you don't know enough. This stuff is simple to understand as long as you break it down to where people can get it. But pretty much that's all I got at this point. We can discuss further. This kind of counts as a ShadowCast this week, so sorry guys if there's no ShadowCast 52, but technically this is it. So that's all I got, man. Hypervisors exist, microkernels exist, and Nintendo's probably going to keep that for the foreseeable future. Do you play games to have fun, or to impress other people?